As a continuation to what we covered last sections, which use a point and a slope to graph the line, I want to extend this to using a slope-intercept form. Now the intercept, to be more specific, the intercept is the y-intercept and not the x-intercept. Okay, just be very clear about that. And the way that we represent this slope-intercept form is using this format: y equal m, which is the slope, times x, plus b. B here is the y-intercept. Okay. Notice that if you want to put an equation, a linear equation, back to the slope-intercept form, all you have to do is just solve for the dependent variable. In this case, your output is the y. That's very simple. All you have to do is just solve for y. So now, let's take a look at this example. I have, let's say, 2x plus 3y equals to 9. I want you to graph this. Now, we have learned several methods in the past. That includes creating a table, which requires you to solve for y anyway. The second one is to solve for the the x and y intercepts. Now that we learn a new way to slope intercept, I thought I'd like to show you how to get this done using this new technique, which is quite easy to do. First, you still have to solve for the y, which is your dependent variable, by subtracting the 2x both sides. That would be 3y equals to negative 2 times x plus 9, and then I will go ahead and divide by 3 both sides. So then y now by itself going to be 2 third x, okay, that is your slope, plus 9 divided by 3 is 3. This is your y-intercept, and that's all you need for this particular one. Now with that already converted to the slope-intercept format and already identify, the first thing, just like your previous section, is to go ahead and plot your first point. Not using the slope just yet. We always plot our first point, and our point this time is very specific. Our point is the y-intercept. So plot the y-intercept. As you know, the y-intercept will be on the y-axis, and it's crossing over 3. So there it is. Now, since the slope is a rise over run, I'm just going to write out the slope for you to see as rise over run. And this is negative 2, so that means we are going down 2 units, and we are going positive run, which is right 3. So it's good to at least identify on your next move, identify ahead of time where you're going to be moving. I know I'm going to be going down 2 units, so I'm going to go down 2, and I'm going to run over 3 on the right hand side. So that means my second point is right there. I got my second point, and there you have it, your line, using the slope-intercept form to graph. Very simple, very straightforward, as you can see. Alright, so here's another example that I would like to show you. Instead of giving you an equation, I'll just give you a point, an intercept, and a slope. Actually, yeah, sure. Let's take a look at this one right here. Let me give you an intercept. Specifically, it's the y-intercept. So it's going to be 0, negative 2, and here's my slope of negative 2. So, like always, we will have to plot our intercepts, which is a 0, negative 2, and the slope. Please always convert it back to a fraction form. So negative 2 is negative 2 over 1, or you can write it as 2 over negative 1. I don't really care how you want to write it, as long as you pick one and stick with it. So let's say I pick that one. So that means I'm going to go down 2, and I'm going to go 1 to the right. So here I'm going to go down 2, and I'm going to go 1 to the right hand side to get to my second point. So down 2, 1 to the right. And now we have ourselves a line that has a negative slope, just like we have up here. So for this assignment, I'd like you to start on page 207, work on these 5 problems, 14, 19, 30, 39, and 44. Please have these completed. We'll check your answers when you come back the next day to make sure that you have them all correct. If you don't have them correct, please ask.